Much Malik. Currently, I'm a sophomore majoring in computer science with a second discipline in biology. And I've kind of built up experience with C++ just through learning it and also working on projects. And also, I guess, I learned C through systems programming class, which they're quite similar. But in the meantime, I'd say I'll give you about 2 minutes or so to sign in using this QR code right over here. So yeah, it's pretty simple. Just your name and your email. It's just a way for us to keep track of things.
What are you playing right now?
It's one of my favorite artists, Nunjabees. Pretty nice.
Yeah, I think I'm gonna close it.
Gotcha, appreciate it. Okay, so probably just close that and that. All right, so let's get started. So first of all, just a quick review of what we're going to go over, table of contents. First of all, I'm just going to describe what C++ is, kind of in context of programming in general, and also like relative to other languages. The more basics of C++, just like the basic things the first things you start learning when you're doing a programming language, including syntax, and maybe like a few of like the things that make it unique. Speaking of unique, the next I'm going to go into is more depth on those unique features of C++, because I think one of my primary goals for this workshop is to show you the kind of the power C++ has in memory management. And finally of all, we might be able to go over some program exercises. So first of all, I guess by show of hands, which of y'all already have prior programming experience? Just in general, with any language. Okay, and by another show of hands, which of those languages is Java? Okay, so yeah, majority of people. That's good to hear. Also, if you need a copy of this slide for later, or if you need any of the programming exercises that I'll provide and be going through, it will be in the GDSC GitHub repository. Good timing. So let's get ready with this. So first of all, what is C++? Essentially, C++ is a predecessor to the C language. There's also C++, but primarily C. And it's also the ancestor to C#. So some of y'all may have seen C# before. And essentially, the way I like to think of it is that's the exact same thing as Java in terms of syntax. There's some other features, but C++ is a bit more heavy on syntax than Java. And much like Java, it's object-oriented. So the thing was, with the original C, came out in like the 80s, let's say, it didn't have classes. Instead, it had something called structs. Structs, we'll go more into them later. They're essentially just classes, but they don't have methods built into them. So you can't add methods, just a bunch of variables that are associated with a struct. Essentially, C++ is very popular in game development and operating systems. So C in general, one of its primary uses is for operating systems. So I think Windows for sure, Mac, Linux, they all run on C. Essentially because C is very close to the compiler. It doesn't go through those like as many of those extra steps in compiling as say Java or definitely Python would go through in order to kind of compile the code into machine code for the CPU. So I mean, C# already came out, and C# came out after C++. So usually what happens is when something that's newer comes out, people like stop using the older version, they hop onto the newer one. So why do some people still use C++ instead of C#? They're both quite different. And a lot of people stick to C++ for syntax reasons. First of all, the syntax on C#, as I mentioned earlier, is very similar to Java. So some people are just used to some of the things C++ has. Also, there were a few features that I think they took away in C# that C++ had that had to do with memory management. And remember, memory management is the key, kind of key feature of C++. giving you a lot more access to like how the memory is managed, how the memory is handled, kind of a bit more control over certain data types and such, preventing certain errors from happening. All right, so before we start going through some of the basics of the language, we're going to have to, of course, have an IDE to code it on. So what I use personally is VS Code in C++. The process for downloading that does take quite a while. So for the sake of this class, we're going to be using a website known as repl.it. The website URL is right over there. You just type it in. You will have to create an account. It's free. You can even sign in with Google, so it's quite easy. Once you create a free account, it will give you it'll kind of ask you for different templates you can use. I think you have to click on Discover More, and then you just find C++, and he'll have everything ready for you. So he'll have, I think, even the main function ready. So all you need to do is start coding. Okay, everyone's got it down with repl.it. Gotcha. Okay, so I think once you sign in, you should be given a screen similar to this, where you can literally have your first name, last name be anything, it doesn't matter. I think same thing with the experience. Even the last thing, okay, over to continue. This doesn't really matter either. So yeah, start with the free pack. Okay, looks like it doesn't have that anymore. So I think what we should do is we should click on Create REPL. And yeah, this is the template I was talking about. Scroll down here, choose C++, and create REPL. Yeah, so essentially, I think right over here to our right, you can press console. This is where the outputs are going to come in for your code, left files, and the middle right here is going to be the actual text editor. So some of y'all may want to start using C++ on an actual IDE like VS Code later on. So I did provide a link to the YouTube video I used to download it. Made it super easy, super simple. If you do want to use C++ in the future, especially on VS Code, which is one of the better IDEs for it, I recommend y'all try that out. Okay. So let's get started. This should be the first thing that shows up once you create the repo. And this is essentially just a basic Hello World program. The whole purpose of Hello World programs is to kind of get you familiar with like how every program should be started. Basically the things that are required for a program to run. So of course that includes a main function. I think on every language, in order to actually run something and produce an output, you need to have a main function. C is very similar to Java. The name of the function is going to be main, and you may wonder why the return type's int despite there not being a return int. This is something special. Usually the compiler, it's just something that you need to know that, hey, in order to declare something as a main method or main function, just have it be int, although there's not a return type. I guess you could think of it as return 0, but yeah, and same thing with the empty parameters. Like I said, there's no significance to the int or the empty parameters. Just know that this is the way you're telling the compiler, hey, this is the main, this is what you should look to and run. Okay, and everything else, by the way, for example, std, that stands for standard library, and cout, and then hello world, and the include statement we'll talk about later. So yeah, just quick bullet points. So we already talked about the main function, so I want to go over to the include statement, which I guess we could talk about now. Essentially, it's very similar to import. That's the way I would like to say it, where you kind of you basically gather a function or a file from like a different file. from a different package, sorry. And you kind of put it into your own code for it to use. And of course, there's in C, and what I'll talk about towards the end of this is that there's actually a pretty complicated process to this on C, known as linking. But for now, just know that the include statement is very similar to import. And of course, the standard library, std, that essentially just contains a bunch of functions that are commonly used in C, including cout, which is essentially just print. It prints something out to the terminal. And I think a few others are string, more on that later. But yes, string is an object in the standard library for this. And that's how some people choose to have their strings represented. There is one downside to the standard library, and it kind of goes back to our point earlier about C being a very memory-focused language. Usually when we're working with C, we're worried about our memory. We're working with limited hardware, right? Say like a small Raspberry Pi that has limited memory. And the downside to using standard library is that it's 40 kilobytes. 40 kilobytes, of course, on our like behemoth computers, that's nothing. But like on a limited hardware, that might actually that might be too much of a cost. So that's something you have to consider whenever you use libraries, even the most common libraries like standard. And we kind of also have to talk about the two operators here. These are a bit unique to C, and C++ specifically, that I'm sure are not in any other languages, which is the two colons between std and cout, as well as these two arrows. So yeah, operators in C, they're quite special because you can overload them. You could change what they do, more on that later. But essentially what the colon is, it has many uses, but it's kind of like dot in Java where you access something inside of the library that you're using. So std, double colons, and then the name of the function from std, standard. And of course, the two, I guess the two equal or less than operators, I just call them arrows for this. I mean, they kind of as what they look like insinuates. It's like you're putting something into what's called into the function, right? So it looks like we're putting the string hello world into cout. And cout is essentially a pointer that leads to a certain process, and that process prints something out into the terminal. So it's very similar to print. Let's see. So variables and data types, of course, they're pretty similar to Java, to be honest. We have the ints, we have the booleans, we have longs. I want to talk about auto here. Auto is a bit special because essentially it leaves it to the compiler to decide the data type. It's not something you decide. It's kind of like, hey, whenever this is being converted into a certain number, depending on that number's length, I want you to decide what data type would fit that. So don't choose a data type that's too small or a data type that's too large. And as I kind of just said, it's good to use this when you don't know the size of the number or the size of the data type in bytes. That's kind of when people use auto. Also, unsigned integers. Did I put it here? I didn't. OK, unsigned integers, they're a bit special as well. And in order to kind of talk about this, we have to go a bit into how numbers are represented in programming. Essentially, a number is just, we know it's an integer, for example, is of 1 byte. 1 byte is 8 bits. And essentially, the combinations of ones and zeros, it's 2 to the power of 8, which is like 4 billion, I think. So it's a pretty large number, 4 billion, right? And essentially, we can actually, the reason it's 4 billion is because it also accounts for negative numbers. The thing about ints, and something that we never really question, is that, hey, how are ints able to calculate both positive and negative numbers when it's just a bunch of ones and zeros? And usually how that's represented is, in simple terms, one of those ones and zero spots is designated for 0, I think, being like, let's just say 0 is like positive and 1 is negative, right? It's not actually how it works, but that's kind of how we could think of it. 1 means negative, 0 equals positive. And because we're accounting for that, that's like one placeholder that we can't use to contribute to the value of the number. So instead of a byte, it basically like divides the number's actual potential by 2, because that whole byte would have multiplied the combination of numbers by 2. So essentially what unsigned does is it removes that. Unsigned means the number has to be positive no matter what, but in return for the number being positive no matter what, that 1 and 0 that we talked about, for it being designated as positive or negative, we can now actually have that represent the value. So in other words, the amount of the value of that data type, in this case int, it's multiplied by 2. So normally an int is like 4 billion numbers, right? It can hold up to 4 billion. If we have unsigned int, that's kind of like taking that number and adding another 1 or 0, aka multiplying it by 2, which is now 8 billion. So it's pretty useful for that case, for being, once again, on C++, being careful with your memory and not wasting a single byte. But of course, the downside is you won't be able to have a negative as that. And if we do have a negative, that's going to lead to errors later on. So that's kind of what unsigned are. Unfortunately, I think I didn't put it here. Now for SCD :string, as I talked about, and I think the next slide, we're going to talk more about strings, but just know that like how in Java, a string isn't a primitive type. It's not like int or a Boolean. It's a bit special. That's why it has a capital S in Java. It's an object. In C, the thing it's very true for C as well, where the standard kind of provides you with the string object. So if you ever need it, hey, it's there. But once again, the downside is you have to use the standard library, which takes 40 kilobytes. There is another way to represent strings, though, and that kind of transitions onto this. There's, I think, 3 ways to make string. Here, we're only going to talk about 2 ways. The first way is if you just need to make a quick program that you don't really care too much about memory. I think standard is a better way to go, because they handle all the complicated shenanigans on the back end side of it, and you just really need to worry about the data type being string. Now, if you can't use the SCD library for any reason, instead what we can use is a char pointer. So that's, first of all, by show of hands, who here knows what a pointer is? Gotcha. Let's see. We'll talk more about pointers later, but I'll give you all a brief definition of it. It is essentially it's like a pointer towards an address of a piece of data in memory. Pretty complicated. For the sake of this, think of it as this. This right here, this grid, it represents the computer's memory. We can just think of it as the computer's memory. It's not actually it, but of course, for the sake of describing it, let's think of it like this. Essentially, each of these grids, it represents 1 byte. And we know that a character is 1 byte. So essentially, each of these can be a byte. So, as seen. Essentially, what a string is it's a bunch of those bytes lined up consecutively. So whenever we do call the string, we call it to the first one, and then we kind of continuously go through these, right? And you're probably wondering, okay, if we're going to continuously go through each of these bytes in that memory, when should we know when to stop? And that's what this /0 is for. We just call this null data because this is supposed to insinuate the end of the string. So as seen here, char star, in the memory, we would have capital B, and then right after that, like 1 byte later, capital Y, 1 byte later, capital E, 1 byte, exclamation mark, and then 1 byte after that, we would have the /n for the null. And that would kind of insinuate the end of it. So the compiler knows when to end. So that's another way to represent strings. The const here, by the way, that's just a keyword that means that this can't be changed. It's very similar to final in Java. So moving on, I think. And at the bottom here, this is one of the ways you can is that right? Concatenate a string. So essentially, string concatenation is just where you add a bunch of strings together into one large string. And usually, on most languages, you would just need to use a plus for that. On C++, instead, you need to use the insert, I guess. We can call this the insert operator, again, just to represent plus, because you can kind of read it from right to left. We're like saying, hey, char array, which is right there, by, that's going into this empty string. So, and then we have the empty string with by in it now going to standard string, which is now hi. So we do the same thing into the function c.out, which then leads to the terminal, and that's how we get the whole message printed. That's how I like to think of it. Okay, so especially after the last one, it was a bit complicated. So if you guys have any questions about that or the data types, maybe something about C in general, let me know right now. before I move on. Yeah.
When you're concatenating, do the strings have to be assigned to a variable, or can you just use like strings?
So it could be either. It could be a string itself, or it could be a variable that represents a string, right? Because in the end of the day, these are strings. We just choose to have it be the variable instead of the name. So yeah, just think of all three of these as strings, except this is a variable for the string instead. The compiler will see the two as the exact same. So, okay. Just a quick reminder: if you want to look back at some of this code, the GitHub will have all of the examples provided, as well as these slides. Now on to control flow. Control flow being if statements, for loops, and all of that. It's essentially the same as Java's. So C++ and Java have pretty identical control flows. Let me see if I have that. Okay. Well, essentially, all of these are the same. Break and continue, those keywords as well, into ternary operator. Kind of skip over this. Now on to arrays. Arrays are somewhat similar to Java as well, in that you create them as follows, where I think these are different ways you can create an array. First of all, if we want to create an empty array of a certain size, we just declare it with the name, of course, and the data type, and we just specify the number in there. And of course, if we're creating an array and we're also putting values into it, it's very similar to Java as well. Now let's talk about getting the size of the array. So in every language, to get the size of an array, there's a function for it, because the array is an object, so they'll have a dot length function. C is a bit different, because we are kind of strict with how we use memory, and there's usually a lot. There's actually a smarter way you can calculate the memory without having to use the dot length function, which dot length might end up taking a lot of space by kind of using a for loop to calculate everything. And that's essentially what these. That's essentially what this for loop is for. So we're just iterating through everything inside of the size of large purchases, so the size of this array. Now, let's talk a bit about the size of operator. It's essentially, it tracks how many bytes something has. So in this case, size of large purchases, it's the number of bytes the array of size purchases has. In this case, it's 4, I think, integers. So it would essentially just be the number of bytes in an integer, 4 times 4, because there's 4 integers, 16 bytes, right? And size of int as well. Of course, we all know the size of ints. It's 4. And essentially what this would do, actually, is this would calculate the size. Because what we're doing is we're taking the amount of space the whole array takes, and we're dividing it by the amount of space each element in the array takes, the amount of data each element in the array takes. Of course, because this is an int array, and we're doing size of int. So yeah, by doing this, we actually we skip the process of having to do a for loop to calculate each of the values of an array in order to get its length. Instead, we just do one calculation, and we get it. And of course, there's also, similar to, I think, Java as well, there's also array lists. Array lists are different from arrays in that you could add and delete things from it without having to worry about like the size still being the same. So essentially, it's very similar to lists in Python, where like you can keep adding things onto it or deleting things onto it. You don't just create an array of like size n and you stick with it. And essentially, it's very similar to Java on C++. As well as many other languages, and this is essentially how you create it. So as you can see, standard library already has an array list for us. They call it vectors, by the way. I know vectors usually mean something else, but in C++, vectors are just array lists. And the data type, of course, the same. And finally, just want to quickly go over matrices. Matrices being a list inside of a list. It's very similar to Java as well. You just use 2 brackets to declare it. The size in the first bracket doesn't really matter. What you do want to declare, though, is the size of the arrays inside of the actual large array. In this case, there's 3. Yeah. just a new feature. Okay, just quick show of hands. Does everyone kind of get this, by the way? Because size of it is quite important to know. Okay, good to know. And I think finally what I was going to include here is the two different type of for loops you can have. Basically the same as Java. Same point I made earlier. Control flows, pretty identical to Java. Both of these mean the same thing. And you can kind of think of arrays as like a pointer to a consecutive amount of memory as well. Kind of like how I talked about, which basically they're pretty similar to strings, right? Where a string can be seen as a kind of an array of characters, where it's like a bunch of characters, and at the end there's like the /0, the null, that indicates the end of it. Arrays are quite similar. Essentially each index in an array, so like usually, like for example, array of 0, array of 1 starts at 0, that stuff. It's a pointer actually. It's a specific block of memory inside of that grid we talked about of like multiple numbers. And essentially what that allows us to do on C is something called pointer arithmetic. So in order to understand what pointer arithmetic is, you need to first understand that of course it's like kind of a block of memory right there. And each of these is 1 byte. That's yeah, each of these is 1 byte, right? So for the case of for numbers, if we're dealing with numbers instead of characters, essentially each number we represent, like 300 for example, it would take up 4 of these blocks, and it would be a combinations of zeros and ones to represent the number 300. These are actually bits, no, they're bytes, yeah. So we could think of it like that. And essentially what pointer arithmetic allows us to do is by actually adding and subtracting the address of this data. The address of the data is just a bunch of numbers as well, right? And I might talk about that later. But essentially each address, yes, is just an integer that represents like the location as a bunch of numbers. What we could do is if we add the size of one integer to that number in the address here, what that does is it like kind of goes over that. Because if we're talking about contextual memory, essentially this spot right here is like 0, and then this spot right here is 0 plus 4 bytes, right? Or sorry, 0 plus 1 byte, and then 0 plus 2 byte, 0 plus 3 byte, so on and so forth. So what we could do is we could do something special with arrays where instead of like the limitations we'd normally have within like for loops and different indexes, we can kind of we can like use special mathematical functions to like do pretty special things with arrays that for loops can't really do. Because for loops, they're pretty simple, right? You either iterate through the whole array, or you like skip 2 every time you iterate, or you like go backwards. But by doing pointer arithmetic, we could like kind of create a function that like adds or subtracts a certain amount of bytes based off of this and based off of that. Essentially, because we're working with numbers and pointer arithmetic, we have a lot more control over which number we go to next inside of the array. So we can finally go on to some of the unique things in C++. Essentially, memory management. I definitely want to highlight that because the main reason people use C++ is, apart from video game development, kind of managing memory and also kind of being closer towards the CPU, which is very important in operating and creating operating systems like Windows. And there's certain features C++ has to make that a lot easier and to give you a lot more control. But there's also a trade-off to that. So in coding, there'll usually be trade-offs in coding, of course. And in this case, the benefit we get is we get a lot more control over how our data is handled, right? But in exchange, that means that since we're getting a lot more control over what's happening, that means we're more likely to make an error that usually the compiler will like handle that stuff for us. No, now we're actually doing that ourselves, and we might be more prone to error. And if we make that error, it might be a lot harder to fix. So that's kind of the trade-off. You get more accessibility over how the memory is handled, but in exchange, it's a lot harder to handle that memory. So let's go on to that. So it's a pretty long sample over here. I kind of mean to go over this through VS Code, but this is so y'all know what I'm talking about if you ever look at the slides. Okay, password. So there's kind of many uses for pointers. One of the main ones is essentially passing by reference instead of passing by value. So essentially, let's quickly talk over what passing by value and passing by reference is. So essentially, what passing by value is when you essentially call a function, you usually put something into the input and you get an output. What happens in pass by value is the input you put in, the function creates a copy of that, and it kind of gives you back what you put in. So the thing you put in keeps its value, just gives it back to you, and the thing that you put in, it ends up creating a copy and working with that. And that's essentially what's going on here, right? So whatever you put in for value in the main code, in this case, y, which is 5, we put 5 into there. What it's doing is it's creating a copy of y, so 5, and it's giving us back y. So y is still 5 after this, and it's returning value plus equals 10. It's essentially adding 10 to that copy it made. So if we were to return it, essentially we would get 15. And the main thing here to know is that because we're passing by value, we're getting back a value that's worth a 15, and our y, whatever we put into it, is staying 5. Sometimes you may not want that to happen. Sometimes you don't want your input to be copied, right? Especially in C, because C++, because once again, data is very important to us. We're very strict with how data is handled. That's where passing by reference comes into play. So when we pass by reference, we essentially skip that step of copying the input and giving it back. Instead, we actually take the input and we work with that. And essentially, when we finish our function and we give you the result, whatever happened to the input stays. So in this case, if we pass by reference, pretty identical to the function below, pass by value. We're putting x in this time. X is also equal to 5, so yeah. This time what the code does is it takes that x, then we're just calling it reference variable, and we're adding 10 to it. But keep in mind, we're not copying x. We're not creating a new x that would take 4 bytes. Instead, that x that we already put in, we're now adding 10 to it, and we're returning, let's just say we also return something here. That doesn't make sense. In this case, it wouldn't make sense to return it, actually. The reason it wouldn't make sense to return it is because what the changes we're making to this stay, right? So we wouldn't need to return it because essentially x is already going to be this number. Yeah, reference bar. Yeah?
What does the and mean next to the in on pass by or modify value by reference?
It's a good thing you ask. So that's a good transition onto the next part of C++ and memory management, and that's essentially addresses, right? If you remember when I talked about point arithmetic earlier, I basically said that every single piece of address in a computer can be represented as a number, an integer, right? Once again, just a bunch, you could just think of it as like a really complex number that represents a piece of memory. And inside of that piece of memory, we can actually have a value b in it, right? So in this case, we can have those two be x and y, right? So say in some piece of memory we have x, and some piece of memory we have y, right? And these each have the value 5 inside of them. Essentially what we're doing is we're going to use pointers. Pointers are, as I said earlier, a special type of integer variable that doesn't, the value of the integer variable is an address. And it's an address to something else. So it exists as an int, and its value, instead of being like a value we give it, like 5 or 6 or like a random integer, it's the value of an address of something else. So let's create that. We have a pointer for x and a pointer for y. And the syntax here for creating pointers is we usually use a star for pointers, right? In this case, when you're creating it, you need to declare the type. In this case, we have an integer pointer, so a pointer pointing towards an integer data type, int point. And we also use this ampersand right here. So when we're talking about dealing with data in C, there's two different types of operators we need to get used to. That's, of course, the star representing a pointer, and also the ampersand. The ampersand, essentially, it just means, hey, this is the address of this value. So it's not the value itself. This isn't 5, actually. This is going to be that long, complex number we talked about earlier that represents its address in the memory. So essentially what we're doing in this line is we're creating a pointer from pointer x towards that address of x. So you might be asking yourself why doing this is useful. And essentially, we can kind of walk through this code and explain. Should work. OK. Yeah, debugging this actually would make it a lot easier to understand. So just a quick run through. X right here, and all the values of our variables will be at the top right throughout the whole process. So for x and y, that's 5. And if you notice, pointer x and pointer y, that's essentially how addresses are represented in C. Like I said, it's just some complex number. Right now, you don't need to understand specifically what the number means or how to decipher it. Instead, you should know hey, this number belongs to this variable, and that we can kind of track that onto something else. So essentially, before modification, I'm gonna crash out over this, bro. Okay. Before modification. So just going back, when we pass by reference, what's going to happen to x?
It's going to change.
OK, good point. In this case, when we pass by reference, that's not going to work. It's going to give me an error. Shoot. OK. Cross fingers that won't mess up on me. Yikes. OK. Should have fixed that before I launched this. Yeah, so essentially, it changed the value of x itself, which we'll see down here. What's going to happen when we pass a variable by value? What happens to the variable we put into the function?
It's going to stay the same.
It stays the same, right? It gives us it back, and it creates a copy of it. So yeah, we just print the 2 out. Should have an updated value of y and such. And voila. Yeah, so x actually changed its value because of what happened in the function. Meanwhile, y, although they did the same thing, they added 10 to the input, the thing we put into it stays the same. I really want to. I think I have no choice. Referencing x. OK, so another neat feature of pointers is that we can have multiple variables point towards the same address. Because once again, when it comes to the actual value of a variable, there's only one of that variable. Sure, we can copy that variable, but when we copy it, it gets a new address, right? Meanwhile, if we keep track of the address never changes, and we have a bunch of different newer variables that might have an address wherever, the important fact is that these variables, the value of the variables is kind of the address of the thing that we are focusing on, right? So if we have multiple things pointing towards one thing, if we change that one variable, that kind of changes the value of everything that it's pointing to, right? And that's a neat feature of pointers. And I think that's what I'm doing here. So we have ref x equaling to x. And notice how the int here is an ampersand instead of a star for pointer. That essentially just means that ref x is going to be the variable of the address, not a pointer towards the address, but just the address itself. Yeah, so see, ref x is the value of it, right? That being 15, which I think is what x is right now. Yeah, so the neat thing is essentially because ref x is a reference towards x, if we change whatever the reference of x is, that changes x as well. And that's kind of what we did here, right? We set the reference equal to a number, 20, and as a result, when we printed out x, we get the number of ref. So that's pretty important. And a good feature of pointers and passing by reference is that we avoid having to create a copy of something. And in C, that could actually be, it's a very neat feature in C because if we have a class that's like a gigabyte large, like a very large class, and we pass it into a function, we don't want that function to create, like kind of allocate a gigabyte of memory for that thing it's creating, the copy, and then working with that. Instead, let's say we could kind of save that whole process of copying a gigabyte over and spending that memory on essentially modifying the class itself instead, which, of course, achieves the same result without having to spend all the gigabytes. And let's talk more about heap allocation. So we have pointers, and we have another thing. We have heap allocation. So in order to understand what that is, we need to know what the heap is. Essentially, here's how I like to think of it. There's two types of memories in a computer. We have the fast memory, which is the stack, and we have the long-term memory, which is the heap. The stack is essentially short-term memory that you would need quick access. You would need basically for things that you need quick access to. So like local variables, like integer variables, and function calls. Not the functions themselves, but like kind of the line you use to like call a function. So that's kind of like you just basically write the function and you put the variables in it. That's the stuff you would need in the stack. And essentially, the kind of main thing about the stack is that once you leave the scope, so like say you leave a function, everything that was created in that function kind of gets deleted. It gets neglected by the CPU. And sometimes we may not want that, especially in C. Sometimes we may want to kind of have something exist outside of a function it's created in. And essentially, that's what the new keyword is for. So the new puts the memory into the heap. And essentially what the heap is it's long-term memory. So while the program's running throughout its process, let's say regardless of where the program may go, from the main function to another function to maybe even another class, let's just say, those variables will still exist. So they're kind of global variables in that sense. And the neat thing is these types of memories in the heap, they basically won't get deleted unless A, you explicitly tell the computer to delete it through a certain keyword, or B, the code just ends. Because when the code ends, it just ends all the processes along with it. So for example, what we're doing here is we're creating an integer. And notice how for new, I'm actually specifying the data type. So when you use new, remember, we're allocating a piece of memory. So what we should tell it is we're allocating a memory of how much. In this case, we're going to allocate a memory of 4 bytes, and an integer is 4 bytes, because we're going to be storing an integer into here. So that's essentially what new is for, new int. And then you store whatever you need to inside of it. In this case, let's put 100 into it. And once again, delete, essentially, we're explicitly telling the computer, hey, we don't need this memory anymore. You can get rid of it. So yeah, definitely a lot to know about when it comes to memory management. But these are kind of the more basics of C++. There's a lot of tricks you can use with pointers, apart from just kind of the main use being passing by reference. For example, what I talked about earlier, pointer arithmetic with arrays, giving us more control over how we go through an array, which may be useful in some situations. And of course, different tricks we can use with some of these functions, like size of, aka remember when we were able to calculate the size of an array by, instead of using a for loop, where we go through every element in an array and counting it, we were able to just calculate it based off of the amount of space the whole array takes divided by the amount of space each element inside the array would take. So any questions about that data management? Okay, let's talk about operator overloading. So this is another neat feature of C++. And essentially, so far what we know of operators is, hey, we have the plus, we have like, we have the equals equals, we have kind of the two ampersands for like and a conditional statement. And something we could do with C is we can actually change the meaning of those. So I want you all to think of operators, literally every operator. So like these two pointy, basically the into function, the into operator, the address operator, the plus operator, literally every operator, just think of it as a function, because it really is just a simplified function, right? So essentially, in C++, we're allowed to change what those functions do if they're used with a specific class. So for some situations, we might need to change what plus means. Of course, let's think of math for a second. Essentially, vector addition is different from normal addition. When we're adding two different vectors, we don't just add like the number of the first one's magnitude plus the magnitude of the first one's magnitude. We add their components, their x components and their y components together. And of course, we could have a function that does this, but for simplicity, we can also just use the plus operator when it's used between two objects of a vector class. And that would make the whole process more simple, especially when we're doing a lot of vector addition. And of course, there's more than that. There's more than just vector addition. There's more than just overloading the plus. So in this case, we create a class for private, we have the variables, and for public, we have the constructor, where x and y are going to be the x and y components of the vector. So it's a 2D vector. And essentially, this is how you overload. Let me just double check that's you do it. Vector chain plus vector n plus 1 plus 2 sum of vector 1s plus operator plus. So sorry, this function right here is actually how you overload it. There's some special things you have to mention. So I think right after the name of the function, you have to use the operator you're going to overload it with. In this case, we're using plus, so that's why it's a plus there. And a lot of the times what people do is they'll have the overloading function be very small and simple, but it'll essentially just call another function that actually handles the processes. In this case, that's what I did. So inside of here, what we're going to do is we're adding this vector, so the vector of the current instance of the vector, along with another vector, of course, of the same class, together. And it calls this function, and this is where we actually do like the overloading. So anything special that we want to do apart from adding, in this case, we're adding the components, so we're going to add the two x's and the two y's, and we're going to return that as a vector object. So it returns a vector that has an x that's like the first x plus the second x, and a y that's the first y plus the second y. Gives us the sum of the two vectors. Yeah. That's weird. So just quickly seeing that in work, we have two different vectors, vector 1 and vector 2. For vector 1, our x component is going to be 1, and for vector 2, our x component is going to be 3. So remember, we're overloaded the plus operator, so now when we add these two vectors, we're going to add the x component of the sum is going to be the two x components added. So it's going to be 3 plus 1, 4. And the same thing for the y component of our sum vector. It's going to be 2 plus 4, 6. So essentially, dude. Oh my gosh, okay. Thanks. Okay, so yeah, for vector sum, just as I specified earlier, because we overloaded this operator, it did what I talked about, and our product is going to have an x4 and a y6. So another neat feature of overloading operators is that we could do it with equal sign as well, right? So you may be familiar in Java that you can use the two equals for integers, but you can't use it for objects like strings. For strings, you have to use the dot equals. So it would be string 1 dot equals string 2, and it will return a true or false if they're equal to each other. And the reason why it doesn't work normally than others is because string is an object that has many unique features to it, like members and such. And so there needs to be a special way that you see that they're equal to that maybe the Java doesn't normally do. And the same thing works for our vectors in this case. We want to see if we want to see how these two vectors are equal. They're two complex objects, so we need to like kind of tell the compiler, hey, this is how I want to determine if these two are equal. And of course, the rules can be anything. In this case, I'm choosing them both to be equal if their components are equal. So of course, we're just overloading it. 2 equals after, that's what we're overloading. We're comparing it with the second vector. That's our input. And it'll essentially return true if our x's and y's are the same. So let's see. So in this case, I'm pretty sure, yeah, vector 1 and vector 2 aren't equal. So we'll probably get this message over here that they are not equal. And the last thing that I want to show you guys is the overload operator. So you guys might also be familiar in Java with overriding the toString method. So every object in Java has a toString method, and essentially what it does is when you call it, or whenever the object is like being printed out, it gives you something special from the class. So by default, it's just where it is in the memory, so it's like a random numbers that represents where it is. But similar to how we can override the toString to like tell us something special, like, hey, the height is this, the x component is this, the y is that. We could do the same thing in C++. And one neat way of doing it is instead of relying on a function like toString, we can override the into operator. Because usually we use into when we're inserting it into the cin, what's called the cin pointer, which prints it out into the terminal. So doing it, once again, it's very similar to everything else where you mention what's called the name of, basically you mention that, hey, I'm overloading an operator with this ampersand operator, and then you tell it which operator you're overloading, which is the into. And we're just going to print out the x component, comma y component. So whenever it's whenever we're using this, that's essentially what it's going to print. In this case, that should be what we get. Did it never print? So in this case, I think it happened here. So sum of vector 1. So it actually happened up here earlier. So we use vexsum, and then that's essentially because we're printing it onto something, it gave us this as the output. It's x component and a y component formatted in that way. So you can see how this can be important for things other than vectors. Perhaps not addition. I don't think there's any other use for overloading addition other than vectors, but the equals definitely for like just basic classes. Same thing with the pointing for like changing how it's printed or however the stream's inserted. X modifiers, we can ignore that for now. Okay, on to compiling and linking. So I kind of want this, I don't want this to be too complicated, but I also want to tell y'all about the main things that set C++ apart, and one of which is that you have control not only over how data is managed, but you also have control over how the code you make is compiled and how different pieces of code from other files are linked to the main. And there's keywords for this, there's different statements. Let's just go over some of them. First of all, more, I guess, formal definition of compiling. Basically, it converts the text file you make, the .cpp file, into a runnable.exe file. So yeah, that's how C works. C, C++, and C++, maybe even C#, when they finish, they actually convert the code to a .exe file, which is better for systems programming because exes allow you to do a whole lot of cool things. And essentially, C++ doesn't, although we're making files and although I'm talking about files because that's what we understand, C++ doesn't actually work with in files. It kind of works as something separate from files known as translational units. And that you usually need to know that for some of the more complicated compiling and linking strategies. But essentially, yeah, files are, although we use them for C++, they're not actually how the compiler reads C++ code. It reads it through translational units. What a linker does is it finds functions from other files or other methods in a class, and it basically links them to the main function. So it's pretty similar to what we're doing with other languages. A good example of linking is if we imported, that's not a good example. A good example is if we import a math function from java.math and we use it in our main. Essentially what the compiler is doing is it's like looking inside of that imported function for the function we're using, and it grabs it and like puts it into main for us to use. And it compiles that as well. And usually it's good practice when you're going to use the linker to declare all of the functions that you'll use on top of the main. This is known as function declaration. Essentially what function declaration is instead of like typing the whole function, so that includes the name, parameters, the actual body, you just tell the compiler, hey, this is my function, this is the name, and this is its parameters. I'll actually put stuff into it later, further down the code, but I need you to know that this is the function and it exists. And it's important to do that because that allows you to kind of have a little bit of control over how C++ links different things. So one of the most popular keywords for this is the extern keyword. And essentially what it does is it tells C++ to only look for functions that are outside of the main translational unit. In this case, we could just say file. So instead of your main file, if you have a specific function, basically if you have a function that has the same name same name inside of your current file and something you want to use that's outside, you can use extern to tell it, hey, I know there's a function that has the same name in here, but I don't want you to link that. I want you to link something outside. And of course, there's many others. And that's linking. We also have compiler directives. So we can also kind of control how code is compiled in C. And once again, this is a trade-off I was talking about because this gives us more control over how things are compiled, so we might be able to find ways to compile our whole thing quicker, but that might come at the cost of, because we have more control, we're more prone to mess up with it. So heading over to here. First, I want to go back to the include IO stream. IO stream is, it's not the standard library, it's not. Okay, it is. Essentially what include does is it gathers whatever is inside of it, in this case IO stream, that library, and you can just think of it as copy and pasting the whole thing on top. That's kind of what the compiler does, and even the linker to some extent. It sees that, it says, okay, grab whatever he told us to, just copy paste it up here. Linker will see the function, it's above the main, so linking is fine. You can do special things with that. And so we also have define. Define is usually used when we're like trying to check for errors and such. Just when we're coding carefully, we want to use define. And define is kind of a way of telling the compiler, hey, this like exists as kind of a global, let's just call it a global variable. And it's usually used for constants because we never really change constants. In this case, pi I just used, but this could represent anything. Also, it's like the fifth ad, bro. Money hungry. Okay. Define circle area. It's also used for defining. We can also use define not only for constants, but for something I call macros. Macros are essentially kind of like functions, except they're functions that can't really be changed. They're constant functions, right? So there are things like, some examples we might want to use for it is math functions. Math functions don't really ever change, especially like finding the area of something. And once again, define is just a safe way to do this. You could just create a constant function and it'd work the same. But the reason why people use define instead of creating those constant functions I talked about is because of another processing statement known as if define. So a neat feature is that we can kind of treat these as conditionals, right? We can kind of treat these defined statements as conditionals. And what we could do is in our code itself, if a certain thing isn't defined, we can run a specific piece of code. And this can be very useful if we kind of exploit the fact that we could change what define does for different, let's say, systems, right? So basically, if you see a program that runs differently because it's on a different system, like let's say if it's on a Mac instead of a Windows system, the reason why is because at the top, it creates a define for something that can only be defined in a certain operating system. So if you're on an operating system, the define will work. But if you're on a different operating system, it won't be defined. And then when you walk into this if defined statement, that essentially means it will run, let's say, something else. Like, hey, you're running this on something other than Windows, blah, 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 I'll run this. So yeah, and also another important common standard function like cout is cin. Cin, you can just think of it as scanner in this case. So much like how cout takes something and it prints it out into the terminal, cin does the inverse. Essentially, you put something into the terminal and using the opposite arrows pointing towards arrows, pointing inwards, it takes whatever stream that is or value and it puts it into radius in this case. So if you type like 3 in the terminal, you press enter, c.in basically using this, puts it into that. It's very similar to like scanner system.in basically. So yeah, and just a quick example, I guess. In this case, we have advanced feature defined. So this part code, we should get this print message out. Shouldn't have done that, whatever. Okay, it gave us the area, and yeah, advanced feature is enabled. Now, for whatever reason, if we weren't able to define this, so I guess we could just write it as that. Now we could just have it print something out instead. st.cl. I guess it doesn't matter. In this case, we could type something down here if we want. In this case, I guess we won't. It'll just return 0. So yeah, just know that end if is essentially, we usually won't have to, so like when you're normally writing an if statement, you don't need to write like an end if, but just for pre-processing, when you're doing this type of stuff, it's important to end it with a, what's called hashtag end if, just to tell the compiler, hey, this if statement type of stuff is done. And the last thing I really want to go over is some cool class features that are kind of unique to C++. I think they may exist in Java as well, but these are pretty neat to know, specifically for C++, because they kind of interact well with some of the features of C++, like deleting and allocating memory. So let's get on to that. First of all, we're pretty familiar with having different constructors for a class. Essentially, that means if someone were to create a class by providing only one variable into the input, we could do this. We could set the others to default. And say if someone were to provide nothing, we can, once again, we'll still be able to create the class, but now everything will have to set to a default value. And C++, essentially, it can do this, and it can be a lot more simple. Instead of creating like multiple constructors for every different situation, we can kind of simplify it into one constructor that takes as many variables as I guess you have, and if a specific variable isn't provided, it'll provide a default value for that. So it works for any combinations of variables provided. So it would be, so in this case, this is what I was talking about. It's called an initializer list. And usually how you declare it is you use an empty, what's called empty for the parameter, and you add a colon just to tell the compiler, hey, this is a initializer list. And then you list off the default values for everything that's not like listed. So in this case, if someone were to only enter a GPA, a double for the GPA, then the GPA would be whatever they provided, but we would default age to 0. And it's the same thing vice versa, where if they provide us with an age but not a GPA, then we'll default the GPA to 0, and we'll give the age as whatever they give us. So if we have like, you can see how this could be useful. Say if we have like 20 different things to put, instead of creating a common, like 20 factorial different constructors for each combination, we could instead just have one where if whichever ones they don't provide, we give it a default value. So it saves a lot of time. And of course, we have the typical regular constructor you guys are familiar with. This just, this arrow is just C++'s way of saying this dot dot and this dot, whatever the name is. And there's two special type of constructors that are pretty nice with C++, especially since we're talking about C++ here, where, once again, we're very strict about how we manage memory. We have the first one being a copy constructor. So whenever objects get copied into like a new variable, essentially what the compiler does normally is it just copies all of its values over. But we want more control over that in C++. Because sometimes if the object's a gigabyte long and we want to copy it, maybe we could minimize it. You know, we could be like, hey, we might not need this type of member. We might not need this member. That takes a lot of data. Instead, we can just have it give like half of the code. So now if we copy it, it only costs us 500 megabytes. We lose some things, yeah, but as long as the important fact is that we have control over what gets copied in C++, right? And that's essentially what this is. So in this case, the ampersand other, once again, that's just the address of other. We kind of put that as the input for this constructor, and that's its way of copying. I'll show you guys down below in main kind of what it looks like. But essentially what we're choosing to do is we're choosing to have the age be the same age and the GPA be the other one's GPA. So we're actually not doing anything special here, but back to my example earlier, if we have 20 different values associated with this, we can choose to like have different values be neglected in our new copied version. We can like set it equal to 0 or something so that we don't have to copy the large heaps of data. Or we might be able to do something special with this. Say, what if whenever it's copied, we want to add 1 to age. So like every year in this program, we would just copy it onto a new one. We wouldn't have to worry about updating the age because whenever we copy it, the age gets updated +1. So that's like kind of some neat things you could do when we're copying. We also have a destructor. As it sounds, it's basically the opposite of constructor. Instead of code that runs in order to create an object, whenever an object gets deleted, we're able to run a specific piece of code. And if you remember, there's 2 instances when an object in a heap gets deleted. And that's A, whenever we call it through the delete word, or B, if we just exit the code. And of course, I should have mentioned this earlier, but classes exist in the heap by default. They don't exist in the stack like local variables or function calls. They will exist in the heap. So you don't need to allocate memory for it unless you want to do it ahead of time. And I guess before we get into that, also let's talk about access modifiers. They're a bit weirder in C++. This is the one thing I actually think I prefer in other languages, and that is instead of kind of using the keyword public private on the same line as a variable, you kind of have to organize everything in like groups of public stuff, groups of private things. So in this example, everything that was public I had to put under this, right? And then everything that was private I had to put under this. So that's essentially how you do it. Unfortunately, there's no public or private keywords we can use. And there's actually a few others. There's primarily 4 access modifiers in C++. There's public and private. We know what those are. There's also protected. Protected essentially means protected essentially means the class, everything inside of its like folder, as well as everything that inherits from the class has access to it. So essentially the class and its subclasses. And we also have something special to C++ called friends. And essentially what this means is you choose which classes have access to these variables via, we can just call it a password, right? So yeah, you get to choose which classes have access to something via a keyword, which I like to call a password. It gives you a lot more control over what has access to something. Okay, and just to display what the deconstructor does, what I chose to have it be, of course how you declare it, by the way, is you use this symbol right here, followed by the name of the class. So very similar to a constructor, and then you have whatever you want to put down below. In this case, I'm just going to say deconstructor called. And we're creating 4 objects. Notice that I only manually delete one of the objects, right, which is the 4th one we create, object heap. And then right after that, the code ends, but let me just show y'all. Okay, yeah, so far we have 4 objects existing, and when we call this, we essentially deleted one of them, so our deconstructor is going to get called. And of course, we can have this be more than just a simple print message saying, hey, this object was destroyed, I'm letting you know. We can have it do something, we can have it do anything, really. A lot of control over that. And essentially, remember when the code ends, everything in the heap also kind of gets deleted. So that would include the 3 objects that have yet to be deleted, which is why when I call this, those objects get deleted, and the deconstructor still identifies that and tells us it. So that's kind of all the neat class things I have to say. I think. Okay, any questions on that? So classes and operators, operator overloading. Gotcha. Okay, is that everything? Okay, that looks to be everything for the slides. That's everything I wanted to go over today. I want to kind of go through everything again. Let me think. How do you get to practices? We could potentially go over a few practice problems right now, actually. So once again, using the going back to it, we can use the repel.it IDE, and once you head onto it, it should default to look something like this. So nothing for terminal. So I guess we can make a basic program that just like takes something in from the terminal and gives you it out. So this is a good demonstration of not only the basic standard functions for printing things and kind of taking things in, very similar to print and scanner in Java. So of course inside of main, we can get rid of this now. Let's have it be age in this case. So age we would represent as an integer. Of course, we can also have this be an unsigned. Let's say like an unsigned short. An unsigned short is essentially going to remember it's going to have the same value as a regular integer, because when we have an unsigned value, that essentially means we won't be able to have a negative of that value, but in exchange, that value will be able to hold 2 times the amount it normally is able to hold. In this case, let's just work with in age. I guess, yeah, we could just print out. Of course, this is the print statement, and we're using the what's called operator for putting something into that. And we just provide it with the string. So sorry, the first line essentially what it did is it, what is that happening? The first line essentially was our first print message, see out, right? So it just tells us enter your age. What the second line is supposed to do is now whatever we type in the terminal, that's going to be age. We're giving that the variable. That's actually, what am I saying? That's going to be C in. Whatever we type in the terminal is actually going to be this, right? And then this operator, of course, puts it into something, in this case, age, so our variable age. So now whatever we put in is going to be age. And I guess we could just print out, yeah, your age is. Well, I think this thing just assisted me throughout the whole thing, but all right.
It's reading your mind, bro.
That's actually, what is going on? That might have been it, yeah. Jeez.
I was trying to type it, it's just
Yeah. Yeah, so age, remember string concatenation. Instead of using pluses, we use this. So your age is blank. Then we have another one, I guess, for years old. That'd be capital. Yeah, I guess that could be it. I guess it's good practice to also have this at the end. What was it again? It's like del or something, right? Okay, yeah, that's the DM line. Yeah, so similar to how it's good practice to have like a \n at the end of everything to represent like a new line. Essentially, C++, you can just use a standard library for that. If I'm familiar, I think \n also works. So yeah, you can use either, honestly. And choose to have it be like this, though. And then we just return 0 at the bottom. That really doesn't mean anything because this is our main. There's no need to return anything. So yeah, it's our code. Okay, let's say, what? Your age is whatever blank years old. I don't know what happened there, but That's why. Okay. Forgot to add a space there. Okay, yeah, that was basically as basic as you can get with a C++ program. Okay, let's see, going back to this. That is kind of everything I wanted to talk about when it came to C++. Of course, I think I'll just go over this because I think I probably could have went more in depth into, where is it? I guess not. All right, yeah, that's everything then. All right.
Wait, we're good?
Yeah, I think that's the end of it.
Wait.
Are there any announcements?
Okay. Wait, go to second slide, I think.
Yeah, QR code.
Okay. Wait. QR code slide.
Okay, there we go.
Yo, okay, listen. Next meeting, which is 2 weeks from now, we'll be doing a web scraping tutorial, right? It will be based off Python, which if you went to the last meeting, you'll know